here we are with Study Guide 2. I'm going to remind you again that you get to use this study guide to help you write your answers on the essay portion of the test, and so having thorough and complete and correct answers here is going to help you get a better grade on the essay portion. However, you do not get to use your study guide for the multiple choice portion, so you're going to want to actually study from this study guide in addition to just using it as a resource. Also remember that there's going to be the practical portion where you need to manipulate the models of the Earth, Moon, and Sun, so we will be practicing that as well. We're starting here with vocabulary. I'm not going to read all of this vocabulary to you. I think that you are perfectly capable of writing it down yourself and checking your answers. We're going to move next to question 2. This should be a familiar diagram to you. Arrow A here represents the force of gravity pulling the planet towards the sun. Arrow B represents the planet's inertia, its tendency to continue moving without an outside force being applied. Remember that the outside force that's able to change the Earth's motion would be so enormous we'd basically have to hit another planet just like the Earth. So, highly unlikely. At any rate, those two factors come together to create the smooth, almost circular orbital path of the planet. In question number 3, we're looking at two identical satellites orbiting at different distances from the planet. We would say that the closer satellite, the 100-kilometer satellite, is going to have a faster orbital velocity. It is going to experience more gravity because it's closer to the Earth. Remember that gravity becomes stronger when two objects are closer together. Number 4, you want to be able to know the order of the planets. Okay, I'm not going to ask you to reel it all off, but you need to recognize where the planets fall. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. This is going to be important because remember that a planet's distance from the sun determines its orbital velocity. Now we're looking at question number 5, the relationship between a planet's distance from the sun and its orbital velocity. Remember that the closer to the sun the planet is, the more gravity it experiences. In order to avoid falling into the sun, since it's being pulled more strongly towards the sun, it needs also more velocity to the side. Therefore, the closer to the sun the planet is, the faster its orbital velocity will be. Number 6, gravity depends on two things. We've already been talking about this a bit. It depends on the mass of the objects and the distance between the objects. The closer two objects are, the more gravity they exert on each other. The more mass the objects have, the more gravity they'll exert. Okay, so it's size and distance. I will never ask you a question that has both different size and different distance. It will always be only one different and the other the same. Number 7, this is an important one, okay? Mass is the amount of matter in the object. It's the amount of stuff that you're made of. So literally, if you talk about gaining or losing weight, you're actually gaining or losing mass. The amount of stuff that makes you up is changing. Okay, your mass is going to stay the same no matter which planet you are on. If you go to Mars or you go to the moon, maybe you'll have less weight, but your mass, the amount of stuff that you consist of, is going to be the same. Your weight, on the other hand, is how hard gravity is pulling on you. Okay, so you could lose weight just by going to the moon because there's less gravity pulling there. You could lose weight by going to Mars because there's less gravity pulling there. Weight is how hard gravity is pulling on you. So your weight will change depending on what planet you're on. Mass stays the same. Now we're looking to number 8. Okay, we have some space probes here. The space probe orbiting Jupiter is going to experience a greater amount of gravity. Sorry, the numbers in the question and the numbers on the picture don't line up, but you can see the numbers on the picture are the same. The space probe orbiting Jupiter is going to experience more gravity because Jupiter is a larger planet and has more mass. Therefore, it's going to feel more gravity. And sorry, my answer for number 9 has jumped down. The space probe orbiting Jupiter will also have a faster orbital velocity since it's orbiting at the same distance but a more massive object because Jupiter exerts a greater amount of gravity.